All right, we're going to do naming polyatomic ions. This is the second to last video that we're going to do. If you'll recall, your polyatomic ions are the 13 that you had to memorize. They were in bold on your polyatomic ion sheet. I actually have that right here. So on the sheet at the very top, you're going to see the bold. Those are your polyatomic ions that you need to memorize. That's your acetate, carbonate, sulfate, sulfite. You have to remember ammonium, chlorate, chloride, nitrate, nitrite, cyanide, hydroxide, things like that. Okay, there's only 13. Memorize them for the test. No exceptions. Okay? So, naming with these is extremely simple. It really is. And I'm going to show you how. So, 3 rules to it. I'm going to write down those rules first. Rule number 1 is going to be the same as it's been. The cation goes first and the name stays the same. So the same thing that's been for simple binary and transition. Cation goes first and the name stays the same. So if I have potassium, it's potassium. If I have iron, it's iron. Chromium, chromium. Whatever goes first, it stays the same. Okay? Rule number 2. This works into your transition metals. You use Roman numerals if a transition metal is present. If it's not, don't worry about it. So this is just if you have a transition metal, you're going to use Roman numerals. If you need help with the transition metals, figuring out the charge of the atom, you need to see the last 2 videos. One is titled Transition Metals, or Naming Transition Metals. The other one's titled Uncrisscrossed, and this helps you find the charge of those transition metals. So feel free to look at those videos if you need to find out the charge. Definitely look at that before looking at this video. Otherwise, you will not be able to name some of these different compounds that we look at today. The third rule is actually the easiest. The third rule for polyatomic ions says that keep the polyatomic ion as it is. Do not change it. Do not change the polyatomic ion at all. So don't change the ending, okay? That is very important. Because if you change the ending, it's going to be wrong. Sorry. The hardest part of these polyatomic ions is going to be the crisscross. So I'm going to show you several examples from the crisscross stage into the naming. The naming is pretty simple. So let's look at a couple of problems for you. Make sure to look at your rules as we go through this. First one we're going to look at, let's just take, I'll just use the periodic table. Calcium phosphate. I know you have them memorized already. Phosphate is PO43 negative. I need to point out a couple things, okay? With this phosphate, it's always going to be capital letters right there, okay? Take a look at chlorate and chloride. That's capital C, lowercase l, capital O, and then the 2 and the 3. Okay? The rest of these, the phosphates, sulfates, stuff like that, are going to be capital letters. Okay? So 1 phosphorus, 4 oxygens. That 4 is a subscript. It shows you how many atoms of the one before it. So 4 oxygens. And the number up top shows you the charge. The number up top shows you the charge. Each of these ions shows you the charge. For example, I want to make sure you have it right. Nitrate would be NO3, so that's 3 oxygens, 1 nitrogen, with a -1 charge. So that will go at the top. So when we crisscross these, let's look at calcium. Calcium's charge is going to be 2 plus. You know that from the periodic table. So when you crisscross these, the charges become subscripts. Okay? So let's look at calcium. The 3 from phosphate came down, and now it's going to be Ca3. And then you have phosphate. The PO4 will always stay together. Okay? Anytime that you have the subscripts in that, so NO3 will stay nitrate, NO2 will stay nitrite, CO3 will stay carbonate. Those will always stay together. Okay? It's only these charges that move and give you a certain amount of atoms. So PO4 and the 2 came from calcium. You notice that I used parentheses. Okay? Here's why. When you crisscross, I'm saying I have 3 calciums and I have 2 phosphate ions. I have 3 calciums and 2 phosphate ions. Okay? So that's what you need to look at there. So let's look at a couple other examples. I'll show you something neat about charges here in a minute. I just don't want to overwhelm you yet. Let's show you a couple more. I apologize for not naming the last one. I believe it was calcium phosphate. I said it several times, but calcium stays the same, and then phosphate stays the same. So naming it's really easy. It's kind of drawing the formulas that's a little bit harder. This one, you have potassium and OH. Hopefully you didn't say IO. I don't know if you dare didn't. But OH has a charge of -1. You know that from your polyatomic ion sheet. So when you crisscross these, you get a 1 down there and a 1 here. You may still do the parentheses, but what I want you to know is that when there's 1s, because this means that there's 1 hydrogen and 1 oxygen, you don't really need it. And you will usually see it without the 1s, or the parentheses in this matter. So if I wrote it kind of how you would normally see it, because that is important, to say, hey, have I seen this chemical before? You would write it KOH. And to name it, first one stays the same, potassium. Second one stays the same, hydroxide. Potassium hydroxide. Okay? And that's it for that. We're going to do iron 2, which is 2 plus charge, and we're going to do nitrate, NO3 -1. You notice I'm going to use my parentheses for naming now, and that's because it's a transition metal. Rule number 2 says that if it has a transition metal, you need to name it with a Roman numeral. So let's first crisscross, and then we'll get to naming. Okay? Sorry for throwing that in there. The charge from nitrate, NO3, this is not nitrogen or nitride, okay? Nitrate, NO3, -1. The 1 comes down, Fe1, or just Fe. NO3, because the charge from iron comes down, we're going to have 2 of those. Remember your brackets. You need to remember always to put brackets there if there's going to be more than 1 of those ions. Okay? So 2 nitrates and 1 iron. So to name this, it's not iron 1. Yeah, you only have 1, Mr. Ullery. Shouldn't it be iron 1? No. Remember, the Roman numerals come from the charges, not the number of atoms. So iron has a charge of 2 plus. Okay? So the charge is 2. So the name of this is iron 2 nitrate. Iron 2 nitrate. Okay? So go and practice a couple of these, and we'll go from there.